The principle of conservation of energy states that energy cannot be created or destroyed. We only store energy, transfer it between objects, or change it from one form to another. For example, energy is transferred between a battery and a bulb. The battery contains a store of chemical energy, which is converted to an electrical current. It's not created. This is then converted into light and also into heat. But what can we say about the total energy in a system like this one? A system is a closed system if the total energy in it is the same after any energy transfer. So basically, no energy is ever added or removed from the system. An open system, on the other hand, can bring in or give away energy, and most systems are open. In a kettle, all the electrical energy given to the kettle is transferred to thermal energy in the water. So a kettle is an example of a closed system. All of the electrical energy that's input is converted and becomes thermal energy. What about the system of throwing an apple in the air? How is energy conserved then? When tossing an apple in the air, all the kinetic energy becomes gravitational potential energy. So as the apple rises, the kinetic energy of the apple decreases and converts into gravitational potential energy. At the highest point, all of the kinetic energy has been converted to gravitational potential energy. Remember that GPE stands for gravitational potential energy. As the apple falls, all the gravitational potential energy it holds becomes kinetic energy. So when the apple falls, the gravitational potential energy decreases and the kinetic energy increases. When the apple reaches the bottom, all of the gravitational potential energy has been converted back into kinetic energy. Some energy will also be converted to heat during this process as the apple collides with air molecules. So the apple itself and the air molecules directly surrounding it will get slightly warmer. So is there a way we can show this concept mathematically? For a closed system, the total energy before a transfer will be equal to the total energy after a transfer. And this is due to the conservation of energy, so no energy is added or removed. Let's consider a plane taking off as an example. If we have an input of chemical energy of 120 megajoules, and the energy is converted into 30 megajoules of kinetic energy, and also 90 megajoules of gravitational potential energy, we can see that the total energy after the transfer is equal to the total energy before. Remember that KE stands for kinetic energy, and MJ is megajoules, a unit of energy. For your exam, you are expected to be able to describe the changes in energy in these and other simple systems, like a kettle or tossing a projectile. Let's have a look at another example. Farah pushes a shopping trolley up a hill with help from Liam, who pulls it with a rope. Farah's pushing gives the trolley 150 joules of energy, while Liam's pulling gives it 100 joules of energy. This gives the trolley 80 joules of gravitational potential energy and some amount of kinetic energy. Calculate the amount of kinetic energy the trolley gains. This can be broken down with a simple diagram. So here we have Farah pushing the trolley and Liam pulling the trolley. For the first step, let's calculate the total amount of energy before the transfer. So that is 150 joules from Farah and 100 joules from Liam. And that gives us 250 joules of energy before the transfer. For step 2, let's state the total amount of energy after the transfer. So we know that the total energy before is equal to the total amount of energy afterwards. And that is 250 joules. For step 3, let's calculate the kinetic energy that the trolley gains. So 250 joules is equal to the kinetic energy plus the gravitational potential energy. We can rearrange the equation to give kinetic energy as a subject. So kinetic energy is equal to 250 joules minus 80 joules of gravitational potential energy. And that gives us 170 joules of kinetic energy.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!